we choose to do a crankshaft. The reason why we choose a crankshaft because it is one of the shaft applications that experience high stress and torsion in its working condition. From the beginning of the project, we have considered many parameters and specifications. The dimension, the shaft layout, the function, the material, and many other things are put into consideration to ensure that the shaft that we have designed are able to work under the load and to operate safely. And the objective of this project is to design a shaft that is reliable and safe.
First, our crankshaft design project was based on the mechanical component analysis subject, which we learn machine components design chapter. We indicate in our shaft design on how to connect element to our shaft. Design based on strength criteria, fatigue criteria, and also rigidity criteria. We use two types of software, which is first, we use Autodesk Inventor, which is a powerful computer application which allows us to sketch, view and edit the design from different directions. Second, we use CES EduPack software. This software allows us and provide a comprehensive database of materials and process information, which is powerful material software tools. Our crankshaft materials is usually made by steel. Generally medium carbon steel alloy are composed of iron and contain a small percentage of carbon. These alloying elements typically used in these carbon steels are manganese, chromium and others. In addition to alloying elements, high strength steels are carefully refined so as to remove as many of the undesirable impurities as possible. Next, which is in describing the load carrying capacity of system beyond the expected of actual loads. First, we indicate effect of associated assemblies or components. Second, thermal cycling and operating or extreme temperature effect. Third, intensity of stress concentration. And fourth, effects of wear. And lastly, influence of fatigue loading over the life cycle of the structure.
The design concept is start with a circle as a base. Then they will extrude out with around 5 cm. Then we will draw two circles on the circle surface, which used for merge into an oval shape. Then the same size for the origin circle is drawn again on the opposite side as in the surface on the oval shape. As our base is done, we will use the mirror method to duplicate the shape with 180 angle like opposite side. A shaft is done, we need to mirror again to make into a long crankshaft. We will mirror at least 2 times for the original size into a long object. Then the second part and third part we will rotating around 90 degree and 180 degree respectively. Then the design for the shaft is done.
Hello, my name is MELVIN A160245, and now the first step that we need to determine the formula is the maximum to determine the angle of maximum bending moment. As you can see, we need to use the formula for the force of the piston, and then we need to find the two horizontal reversal. Therefore, we will get is the two horizontal force with 7.26 kN. And then we need to find the design of the crank pit, and we find out is the L0 equal to 33 mm. And we need to find the design of left hand and the right hand crank rack. The formula for this both are the same. And what is the purpose is to design for eccentric loading. And there will be two stress. One is the direct compress and one is the bending stress. And we need to design on the shaft to prevent for the fatigue loading, and we must be less than allowable bending stress. And we found that our formula is proof that it's less than 75 Nm square. So hence the design is safe. So therefore the finally we use is the fatigue loading. We found that the shear strength that we get is the 57 Nm/mm square. And by using the distortion energy theory, we found it's less than the allowable bending strength. So therefore, the result we get is for the diameter of shaft is 42 mm, thinner of crank rack 24 mm, width of crank rack 63 mm, length of crank pit 33mm, and diameter of crank pit 44mm.
We managed to calculate the measurement of the shaft for it to work in the correct manner. The material chosen is steel, which helps it to withstand a high stress, which the stress analysis indicates that the crank web and the crank pit will experience the most stress, so that place is the most, we need to focus on that place the more. And our best design and the better material will help the shaft to last longer. Thank you.